Today we're in San Diego, California visiting 5DEV to see how they turn a solid chunk of titanium like this into one of the lightest, most advanced titanium stems on the market. I'm here with Leo. He's one of the engineers here at 5DEV, and he's going to show us how we turn this bar of titanium into a stem.
The common joke is, here, I've got your part, it's in there somewhere, you just gotta find it. First quick operation that we throw at this thing is we cut what's called a dovetail into it. It's got this reproducibility slot in it that goes into a pin in our vise.
Imagine if your bar and stem had this little slot in it so it was always centered. That's kind of the same idea. So every time you stick it back in there to get a piece cut off, it's cutting it off at the right angle.
Yeah, we're trying to reproduce these down to the 1,000th of an inch, right? Like a fraction of your hair. And so having the capability to go inspect it on high precision equipment, put it back into the machine, fine tune it, you don't have to scrap out your part. Whereas if you didn't have that reproducibility, you'd have to scrap out the part more often than not.
That's the most titanium I've ever seen in one place.
As you can see, it centers itself right in, locates in X, locates in Y, and now we're good to go to run more of these prototype parts. This is what an end mill looks like, right?
Okay.
So this is made out of tungsten carbide. It's got a special coating on it that reduces the heat transfer to the tool. So titanium, for instance, it falls into like a super alloy category. It's really bad at conducting heat, which is great for a lot of aerospace applications. But for us, when we're machining it, it makes it that much trickier. You know, we use top-end industry equipment, what they use in aerospace manufacturing, what, you know, our bread and butter, and then apply it to these mountain bike parts. And
have you ever made anything for SpaceX?
Yeah.
Really?
Yeah, so SpaceX, a lot of the local defense and aerospace.
So a stem's nothing.
This is fun.
Oh,
it's like, this
awesome.
is fun. Yeah. And titanium, make it a little interesting.
Right on.
So this is like the bulk of it right here, right? Like how do you take all of that titanium and then make it into this little finished product, right? So we take this big rougher end mill and we just start carving away, hogging at it, right?
So I'm starting to see why these are so expensive. You can't make this without that much titanium to start with.
Yeah, correct. Where do you cut first?
Right.
So like we were going.
My brain would be like, oh, I need the biggest hole here for the 35 mil bar. Let's just start with that.
Yeah, and think about that, right? So you remove this huge diameter here at the bottom end of your structure, and now you need to carve away all this material on top, and you've significantly reduced the rigidity of your setup. So it's like, the way I always think of it is like peeling away a banana, right? It's like we're starting away from the top where our main structure isn't.
Yeah.
You know, we rough away all the outsides, we get our generic shape, we start finishing some of these contours, and then we can start getting into some of these finer details to where at the very end, you know, we're cutting counterboards, we're drilling, we're tapping, and we're slitting it right open.
I've never wanted to be an engineer before today, and I'm not smart enough to be one, but this is fascinating, and it sounds really fun taking these creations. And, you know, I don't know how many engineers get to see their final part and then go ride it on the trails.
Yeah,
That's
exactly.
rad.
No, I got my dream job, bro.
This is a stem you're going to have for 10 years and give to your kid when they start racing. 20 years from now, this will still be one of the coolest stems on the planet.
When it comes down to it, having the software and the machines that we do gives us the capability to do stuff like this. To where we can take every gram that we want out of this thing, you know? There's a stem.
That is incredible. It took this to make this and this. A lot of brains, a lot of fancy machinery, a lot of experience. This thing is so light.
Yeah, it weighs nothing, huh?
And so beautiful. Tell us about the material properties differences between like aluminum, titanium, and steel. Can you just give us a quick rundown?
Titanium is about half the density of steel. So you can essentially have the same geometry, half the weight, same functionality, and have a part that weighs half as much for
or half as thick.
half as thick, exactly.
Well, how about aluminum? Like this is fairly heavy. A lot of people think titanium's lighter than aluminum, but if this was aluminum, it'd weigh a lot less.
It would weigh a lot less, yeah, significantly lighter. But again, not nearly as capable in regards to performance. So to get the same failure capability or the same loading capability, you'd have to make the part significantly thicker out of aluminum. Yeah, that's why you see like the big, chunky, you know,
all
gnarly
aluminum things look big and burly.
Exactly, like those big aluminum stems that are
Yeah.
just freaking huge, right? Compared to this thing, it's like, you know.
Well, it's interesting. People are going to have to readjust their expectations because we're used to seeing big, chunky aluminum stems. But if we can get the same strength with way less material, we're going to have to readjust what our brains see when we see this. Because I think some people might see this and say, oh, no way, I'll break that.
Yeah, it's aggressive, right? I guarantee you your frame's going to snap before that
That
goes.
is so cool.
Yeah.
Man, that's light and absolutely beautiful. I've bonded with this little piece of metal. It sounds dumb, but watching it go from this and all the people involved has been so rewarding, and I will never look down at my stem the same way again. The expertise that went into this is laughable. Probably the most over-engineered stem on the planet.
Oh yeah, most definitely. It's a work of art, right?
It really is. Absolutely beautiful.
Yeah.
Thank you so much.
Yeah.
While I'm here at 5Dev, I'm checking out their prototype parts, and we're going to throw on these prototype pedals. You can expect to see these soon on the website as well. And with all this 5Dev stuff, you can use coupon code Hardtail Party to get 5% off. So make sure to use that code when you're shopping at 5Dev. That helps support this channel. It helps them know that you're watching, and it helps you get rad stuff cheaper. Yeah, there's some exciting stuff coming from 5Dev that we're not allowed to talk about. Stay tuned. So we're going to throw these pedals on and try the new stem. I can't wait to see what these things ride like. Oh, those look beautiful with those cranks. All right, these are 35 diameter, and I'm running a 31.8 bar, so we've mocked up some shims. I couldn't let the opportunity go without trying the tie bars with the tie stem. You want to use lots of anti-seize when you're using titanium on titanium. That was awesome to go from a chunk of titanium bar to this stem, to talk with the guys who designed it and the passion behind it, to have it installed on my bike. Next step is for me to take it out on the trail, see what it rides like. If it rides half as good as it looks, if it rides 1% as good as it looks, it's going to be my all-time favorite stem. It's been amazing to see stuff made in the US, made locally by people who are passionate and who cut zero corners, or all the corners, depending on how you think about it. Thanks for watching, everybody. There's a party in the mountains, and you're invited.